Hey guys, this is the key to your very first study guide for physical science. Our very first test is coming up, so let's go over this. Number 1 says to list the steps of the scientific method in order. So you should have question, hypothesis, experiment, results, and conclusion. That is the correct order. But number 2 asks you, does the order you listed in question number 1, this order right here, have to be followed? The answer is no, it definitely does not. Number 3 is asking you to define several terms. I gave you these definitions in your notes, so I don't feel like I need to rewrite them. So go to your notes and find them. And even better would be to put them in your own words. Number 4 says, what form should a hypothesis be in? If possible, it should be in an if-then statement. Don't forget that. Number 5 asks you to write down or draw all of the things that should be included in a good graph. And you can kind of see it already. I drew it off to the side here. I have that your independent variable, whatever you decide that is, you should label this side with that and then put a unit in parentheses. Whatever your dependent variable is, you should use that to label this side of the graph and include a unit in parentheses. Graph should have a title, and it should also have good scales, which we've talked about. And most of the time, it's going to be a line graph. Don't forget that. Now we're identifying independent and dependent variables. So for letter A, the independent variable is whether they watched the cartoons alone or with others. Those were the two groups of people the scientists decided. And then the dependent variable, what they measured, was how high they rated the cartoons on funniness. So I put funny rate. So this time they are giving people two kinds of environments, whether they study in silence or with the TV on. So that's your independent variable. They said these people read in silence, these people read with the TV on. And then what they measured was the results of the comprehension test to see who did better. So then letter C. Some kids had college graduate parents and other kids had parents that didn't finish high school, and then they measured the kids' academic potential. So whether the parents were college grads or didn't finish high school was the independent variable, and what they measured was the child's academic potential. So then we had workers at a company that were put into one of two groups. One group had stress management and the other one did not. So that is your independent variable. And then what they measured was the number of sick days. For E, you had one group of people receive a traditional book while the other group had one on a computer. So that's your independent variable, whether they had the regular book or the book on the computer. And then what they measured was how well they did on the test. So final exam scores. Okay, so now we're graphing in a line graph, and I'll just kind of show you my process here. So first of all, you have to decide which is the independent and which is the dependent variable. So make a question out of this. Did they determine how the amount of fertilizer affected plant height, or did they determine how the plant height affected the amount of fertilizer? Only one of those two questions makes sense. The scientists can't control how high the plant grows, but they can control how much fertilizer they put on it. So this is your independent variable, and this is your dependent, which means I'm going to take this information and put it on this side of the graph. So I'm going to put that right there. There is no unit, so we can't put anything in parentheses, but I wish we could. A 0 always goes right here. And so since this is our dependent, we can write it along the side. And this time we do have a unit, so we have to include it. It's going to be in centimeters. So then we have to come up with some sort of a title. So how high plants grow with certain amounts of fertilizer, that's a good one. So now I just have to pick out my good scales. So I went ahead and marked my bottom scale here. I went by 2s because my biggest number on this side is 40. So that makes it take up quite a bit of the graph there. So then for this scale, the highest number that I had to get to with this information was 17.3. So I just went by 1s because I had 20 lines. So then all that's left to do is to plot your points. And notice that I did not go 0, 13.2, 14.1, 14.9. That's a bad scale. There are different gaps between each number. You can't do that. You have to go by 1s or 2s or 3s or 4s or 5s. You get the idea. It has to be even. And then you find the plots. So amount of fertilizer, down here I'm going to go to 5, which is here. And I'm going to go up to 13.2. So I'm going to follow this up. 13 is there, so I'm going to go just a little higher than that, about there. So there's my dot. And I do the same thing with all the rest of them. I go over to 10 here. And what matches up with that is 14.1. So I go and I find the 14 all the way up here. And it's at 0.1, so I put it just a little higher. And that's how we do it. So you try it on your paper, and I'm going to do it on here. So this is how my graph turned out. So now if I just look at this graph, I can see the best amount of fertilizer that will give me the most growth. So my highest growth was right here. So if I give it 30 fertilizer, then I know my plants are going to grow the best. So that's a good graph. Now, if your graph turns out to do something to this effect, that is a bad, bad sign. A line graph will never double back on itself like this. So that means you've done something wrong and you need to go back and fix it. So you do not want that. You want a continuous line. So here's how I did my graph on the second one. My years was going to be my independent variable because the scientists can control that they go and measure it or look it up once a year. But they can't control how much it rains, so that has to be the dependent variable, which goes on this side, and it's in inches, so I made sure to put that. I've got my years through here, spread out as much as I could, and my graph never doubles back on itself. It just goes up and down, but it continues to the right, so it's looking good. So now for this question, we have this situation, and I'm pretty sure all of you would have read it by now. If not, you're going to be in bad shape for the test. So then it asks us these questions. What is the problem or question for this? This is what I decided. Is a fruit's size related to whether it floats or sinks? I got it right out of here. If a fruit's size is related to whether it floats or sinks. Magical. So then it says, what is the hypothesis? And she says she figured smaller fruits would float, but larger fruits would sink. So that's the answer to her question. That's what she thinks. Good. Now it says, how did she gather her information? She conducted an experiment, which is underlined right up here. This is what she did to test. Next, the independent variable. Well, we did this in class, but we're going to do it on here. I developed the question, so now I just got to underline the two parts, and that'll tell me. So here are the two parts. Fruit size, right there. There's the first part, related to whether it floats or sinks. Remember, every time we underline, the first underline is the independent variable, second line is the dependent. So if you can come up with a question for an experiment, you can figure it out this way. So independent variable, fruit size. Dependent variable, oh look, floats or sinks. That's what they're measuring. Was there a control group? No, she didn't really have a normal. There's not like a standard fruit that floats. So we're going to say no. And then how did she analyze the data? Well, she drew conclusions. Down here, it talks about what she found out. She just found out that size alone doesn't determine if a fruit floats by looking at her data. Then she discussed her conclusion with her friends. She told her friends, and then they gave her a different idea. So that's how she analyzed the data. So this last little part, we're using the metric system. So I went ahead and drew myself one to use on the page, which I strongly advise you to do. It's very helpful. So let's do a couple of them together. We're going to take 23.6 centimeters, so we're right here on our scale, and we want to change it to meters. Since there's no other letter in front of the M, that means it's the base unit. Okay, these all have 2, 2, 2, so they're definitely not base units. They're one of these other guys. But this lone letter by himself tells you it's a base unit. So I'm going to go from centimeters and go to base. So I go 1, 2 to the left. So my decimal goes 1, 2 to the left, meaning my final answer is going to be 0.236 for meters. Done. Do the same thing for millimeters. So we're starting up here at centi, and we're going to go to milli. So from here to there. 1 to the right, decimal goes 1 to the right. My final answer is going to be 236 because my decimal's now at the end right there. Hopefully you can see it now. So now my last one, I'm going from centimeters to decimeters. So I'm going from there to there. So 1 step to the left. So my decimal goes 1 step to the left. So my final answer is 2.36. There we go. Let's do one more line together. So we're starting at 456 millimeters. Millimeters is here. We're going to go to centimeters. So we're going to go from here to there. 1 step to the left. So my decimal, which I can imagine is here, is going to go 1 step to the left. So my final answer is going to be 45.6. Just like that. Now I'm going from millimeters to meters. Once again, it's the base unit because it's a letter by itself. So going from here to there. So 1, 2, 3 to the left. Decimal goes 1, 2, 3 to the left. Final answer, my decimal's in front of the 4. So there we go, 0.456. So now we're doing a big movement. We're going from millimeters to hectometers. So 1, 2, 3, 4, 5. Okay, so I'm going to take and go 1, 2, 3, 4, and 5. So now my decimal's out front here, and each little loop tells me it's a 0, so I'm going to go 0.00456. And there we go. Pretty simple. Whatever you do on the staircase, you do with your decimal. So here is how the rest of mine look. Now, take your time, pause the video, get these written down, but also check them. I may have made a mistake. It's happened before, it'll happen again. If you find one of my mistakes, awesome. Maybe bonus points for you, okay? Study hard. And good luck on your test. We'll review together on Tuesday, and then Wednesday is it. First test in the books. Good luck, everybody.